Pydantic AI's agent serves as the central interface for orchestrating interactions with large language models, encapsulating instructions, tools, and structured output definitions for coherent AI behavior. This example demonstrates configuring an agent with a specific LLM, defining its expected input, DEPS type, and output type, and integrating a custom tool that utilizes RunContext to process dynamic input during synchronous execution.
From Pydantic AI Import Agent, RunContext. Roulette agent equals agent hash 1. OpenAI GPT-5 2. DEPS type equals int. Output type equals bool. System prompt equals. Use the roulette wheel function to see if the customer has won based on the number they provide. At roulette agent tool. Async def roulette wheel text. RunContext int square int str hash 2. Check if the square is a winner. Return winner if square equals ctx. Deps else loser. Hash run the agent. Success number equals 18 hash 3. Result equals roulette agent. Run sync put my money on square 18. Deps equals success number. Print result, output hash 4. True. Result equals roulette agent. Run syncy bet 5 is the winner. Deps equals success number. Print result, output. False.
This code demonstrates the creation and execution of a Pydantic AI agent that leverages a tool and DEPS for dynamic behavior. The agent is initialized with a specific LLM, DEPS type equals int for its dependency, and output type equals bool to enforce a Boolean return from its runsync method, ensuring type safety and predictable output. A system prompt guides the LLM to utilize the defined roulette wheel function. The roulette wheel function is registered as a tool using the @RouletteAgent tool decorator, allowing the LLM to call it during its execution. This tool accepts a RunContext int to access the integer DEPS provided at runtime, enabling it to dynamically determine if a square matches the success number. The agent runsync method then executes the agent synchronously, passing a user prompt and the DEPS value, with the output being the Boolean result of the roulette wheel tool's evaluation, validated against the output type. Let's break it down.
From Pydantic AI Import Agent, RunContext.
Imports agent and RunContext from the Pydantic AI library, enabling the creation of AI agents and access to their runtime context.
Roulette agent equals agent hash 1. OpenAI GPT-5 2.
An agent instance is created and assigned to the variable roulette agent. This agent is configured to use the OpenAI GPT-5 2 model.
At roulette agent tool. Async def roulette wheel text. RunContext int square int str hash 2. Check if the square is a winner. Return winner if square equals ctx. Deps else loser.
Defines an asynchronous function named roulette wheel that takes a RunContext object typed for an integer dependency and an integer square as input, returning a string. The function checks if the square matches the dependency value from the RunContext and returns winner or loser accordingly.
Success number equals 18 hash 3.
Assigns the integer value 18 to the variable success number.
Result equals roulette agent. Run sync put my money on square 18. Deps equals success number. Print result, output hash 4.
Calls the runsync method on the roulette agent object, passing the string put my money on square 18 as the primary input and success number as a dependency, then assigns the returned run result to the result variable. Prints the output attribute of the result object to the console.
Result equals roulette agent. Run syncy bet 5 is the winner. Deps equals success number. Print result, output. False.
The roulette agent, Pydantic AI Agent, executes its runSync method with the input string, I bet 5 is the winner, and passes the success number object as a runtime dependency, storing the completed response in the result variable. The print function then outputs the output attribute of the result object, which is false. This example demonstrates how Pydantic AI's agent orchestrates LLM interactions by integrating a custom tool with dynamic runtime dependencies. The agent is configured with deps type and output type to ensure type safety and predictable output, guiding the LLM's behavior through a system prompt. The @roulette agent tool decorator registers the roulette wheel function, making it callable by the LLM. This tool leverages RunContext to access deps provided during runsync execution, allowing it to dynamically process input. The runsync method executes the agent, passing both a user prompt and the deps value, with the final output being the Boolean result of the tool's evaluation, validated against the output type. This pattern highlights how deps and RunContext enable tools to react to specific runtime data, making agents highly adaptable without altering their core definition.
RunContext.deps holds the truth, yet the agent spins the wheel of fate for a Boolean answer.